Hello everyone! In this video, we're going to solve an exam question in electrical engineering. While studying for an exam, it is important to compare results with friends. I recently debated the solution of this exercise with a friend of mine, who's also an electrical engineer, and I decided to bring to you the solution. The question is about the circuit with two resistors and one sinusoidal voltage source. If we replace the 10 ohms resistor by an inductor, what would be the value of the inductance so the magnitude of the current is preserved? Okay, my friends, this is the question. Let's go to the solution. The first step that we need to take is to calculate the current I. The current phasor is going to be the division between the voltage phasor and the impedance. Okay? Observe that here the impedance is composed only by resistors. Okay? Z is equal to 40 ohms plus 10 ohms. And the voltage phasor is equal to 100 phase 5 volts. Here we're going to consider phi to be equal to 0 degrees. Then the current is going to be 100 phase 0 degrees divided by 50 ohms, which is equal to 2 phase 0 degrees amps. Alright? And the magnitude of the current is equal to 2. Okay? This is the magnitude of the current. Now, what the exercise wants us to do is to replace the 10 ohms resistor by an inductor. Let's do it. Let's do what the exercise wants us to do. And the inductance of the inductor is L. Alright? Now, instead of having only resistive elements, we have now an inductive element in the circuit. Again, the current phasor is going to be the division between the voltage phasor by the impedance. But now the impedance is equal to 40 ohms plus J XL. XL is the inductive reactance. And XL is equal to WL, where WL is equal to W is equal to 2 times pi times F. 2 pi F L, okay? And the frequency here is 50 Hertz. Therefore, here XL is equal to 100 pi L. Alright? Do you guys fully comprehend this? And the impedance is then going to be equal to 40 plus J 100 pi L. This is the impedance. And the current phasor is going to be equal to 100 phase 0 degrees divided by 40 plus j 100 pi L. What we need is to make this equal to 2. Okay? The magnitude of the current has to be equal to 2. The magnitude of the current has to be equal to 2. So, this thing here the magnitude of this has to be equal to 2. The magnitude is going to be equal to 2. Okay? So, what is the magnitude of this? The magnitude of this is 100, because the magnitude of 100 is 100, and the magnitude of the denominator is 40 squared plus 100 pi L squared. This is the magnitude of the denominator, and this has to be equal to 2. Alright? Then, okay, after manipulating this, we find that the square root of 40 squared plus 100 pi L squared is equal to 50. Okay? Is equal to 50. And 100 pi L has to be equal to 30. Alright? We simply pass this root here to this side, and here it becomes 50 squared, and here 40 squared, and we have a Pythagorean square here, 50 squared, 40 squared. Here, the only possibility is 30 squared. And we find that L is equal to 0.3 divided by pi. This is the value of the inductance, or if you prefer, this is 0.095 Henry. Alright? Now what we need to do is to check. We need to check to see if our result is correct. And how do we check this? To verify, we simply do this. Okay? We are going to verify whether our result is correct. So, the current phasor is going to be 100 phase 0 degrees divided by 40 here, and the inductive reactance, we discovered to be equal to J times 100 times pi times this value here, 0.3 over pi. Okay? We cut pi with pi, and 100 times 0.3, this becomes this. 100 phase 0 degrees divided by 40 plus j 30. Alright? 100 phase 0 degrees divided by 40 plus j 30. And if we convert this Cartesian form to polar form, we find this. I is equal to 100 phase 0 degrees divided by 50 phase 36.87 degrees. And then the current is precisely equal to 2 phase minus 36.87 degrees amps. All right? Okay? So this is the current when we put the inductor. Before putting the inductor, the current is simply equal to 2 phases 0 degrees amps, okay, or if you prefer 2 phase 0 degrees amperes. And now the current is equal to 2 phase minus 36.87 degrees amps. All right? The phase changed, but the magnitude has been preserved. And this is exactly what the exercise wants us to do. And the value of the inductance is this. So this is the value of the inductance that preserves the magnitude of the current. Okay, my friends, this is the exercise that I wanted to show you. I hope you learned from it and enjoyed it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!